Okay, so we've seen what product moment correlation coefficient is. That's the R thing from before. Now let's use it to do something. So we've got a situation here, English and maths mark, okay? And we want to see if they're going together. We know how we can enter that data now to get an R value. So here we've got an R of 0.2, for example. So what did we observe on the first set? 0.219. But what is the true underlying PMCC between maths and English? So what do we mean? Well, they were generated independently from each other. So we have to assume to start with that they have no connection. So it's up to us to prove that there is a connection. And that's what we're going to do. We're going to do some hypothesis testing for correlation. So what would this number have to be? Because 0.2 is pretty weak. What would that number have to be with 10 people so that we could say, aha, these go together, that there is a connection between them? Okay, so if we increase the sample size, so we went beyond 10, for example, well, what we'd say is as this number got bigger and bigger, imagine if this number were 1 million, for example. If it were 1 million and this number came up as 0.8, well, we'd have to say, no, the real, the underlying, the true connection for a population between them, that there must be some connection. We could show that if we had more and more people, okay? So how many people do we have to have is important, and what the number is going to be, what we're going to have to compare it to, is going to be important as well if we are going to show that there is a connection. If the sample's really, really small, it will be hard to show a connection, and if the number that we get from our data is not big enough, it will be hard to show that there's a connection as well. So here we go. The assumption is always going to be that this is R, okay? They're using rho. So the connections, the onus is always on us to prove it. So the null hypothesis is always that there is no connection, okay? In this example, we've tried to say that there is a positive connection. So the alternative hypothesis would be that this value is greater than 0. We have a sample size again, so we have 10 pieces of data in this case. What number does this have to be bigger than? Well, the good news is somebody's worked it out for us already. So it exists in the table. It's called critical values for correlation coefficients. So what you do is you find your number. So you go down by sample size. You go down to 10. And then depending on the significance level, a bit like hypothesis testing, there's a significance level. Depending on how strict you're going to be, the number will be different. So here, 10%. So where was 10%? 10% was this one. And if we meet up together, we get this value here. So this is the number to compare to. We get that value from our calculation, and then we look up this value here. So remember, the data says this is what it is. But compared to this, what do you think? This is the threshold. So how does it compare? Well, we need this number to be bigger than the number from the table because we're assuming there is no connection. The connection should be so strong that it's greater than that number there. This is like the minimum benchmark for accepting that something's going on. And you can see here it's not close. It's less, it's nowhere near. So what this means is the data and the size of the sample, at the moment, there's insufficient evidence based on those to suggest that they are correlated. I know there is a positive number there, but because the sample size is low, like look what happens when you have these small sample sizes. You have to have a really high number to prove it because basing it on a few pieces of data is not a good idea. So it's not enough. You'd need to be able to show a stronger connection to believe that there was a connection between them. So let's do another one. We do 30 observations of the masses of reactions, and we want to know if they're connected. So she calculates R equals minus 0.45. So that's the number that we're going to compare with the table. And we're going to see, is this stronger? Is this strong enough compared to the number from the table? So 10% significance testing. The hypothesis is always up to us to prove that there is a connection. So the default is that there is no connection. In this case, she believes that there is no correlation between. She believes that there's no correlation between the masses of them. So this is actually a two-tailed test, isn't it? Because she's not saying that it's greater or it's less than. She's saying that it's not equal. So that's this one here. The sample size is given to us, which is 30. It's a two-tailed test, so it does say 10% significance, but remember, if it's two-tailed, you split that 5% to the left and to the right. So 5%. Now let's look up this number. So 30 is here, 5%, 5% is here. So that is 0.3061. Now, the sign, you can actually ignore the sign, okay? Because the sign just tells you if they go with each other, if they go against each other. So this is what we have observed. And this is the number that we're supposed to test it against from the table. Well, is it strong enough compared to the number from the table? So the magnitude of it, well, yes, it is. It is bigger. So that means that, well, it seems to imply that there is a connection between them. So what we're going to do then is we're going to reject the null hypothesis, that it's equal to 0. And in this case, the alternative hypothesis is that it's not equal to 0. In other words, it's greater or it's less, but we don't know which one it is. Slightly confusing H0 and H1 here, but as long as you remember that the first one is always equal to 0 and a two-tail means that sign there, it's not so bad. Okay, but the observed value is greater than the one from the table. You have shown that something is going on, that there is some kind of connection between them. Okay, so pause the video and have a go here. Step 1 is putting this into your calculator to find this value and then test it at the 10% significance level. To get your number from this, if you just have a look at the Edexcel formula booklet, if you go to the end, you're looking for the PMCC values. So pause here and have a quick go. Okay, so you should get a value of 0.1149. You might notice already that sounds very low. It sounds very low, especially for 8 pieces of data. So I would be surprised if we can reject the null hypothesis. I think we're probably going to be accepting, but let's have a look. So our null alternative at 8, the value from the table, look, it's way below the value from the table. In other words, there's not enough to suggest that anything is going on. So we say there's not enough evidence to reject. So we accept H0. And what they've just done here is it's a good idea to be on the safe side, just to put the situation back into context. So slightly different sort of type of hypothesis testing here. You might remember below that binomial was done in a very, very different way. For this one, you have to show that the correlation is stronger than the correlation that's given to you in the table. So you have to be a little bit wary of that. But that takes you up to exercise 1C.